Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Memis, for this episode of CompTIA Linux Plus. Managing Services with SysVinit is the name of this here episode, and Don Pizzette is going to be showing us the way. Don, good to see you. Thanks for joining us.
Well, glad to be back, Zach. And like I said, we're going to be tackling SysVinit. You know, in the last episode, we got a chance to see systemd, which is the most popular initialization system in Linux right now. However, if you're working out there in the field, there are still many, many systems deployed that use the older SysVinit. In fact, on servers, it's actually pretty common. So definitely something we want to learn about, and that's what we're going to do right here in this episode. We're going to learn a little bit about how SysVinit works. It's a tricky one to say.
So, it can happen to everybody.
To anyone. We'll see how it works. We'll see how to manage it, manipulate it, and just kind of see how to operate in an environment that is running SysVinit.
Fantastic. Don, how are services controlled under Linux?
All right. So basically, all of our services inside of Linux depend on an initialization of some sort, right? And systemd, we've already seen, is one way, right? Your system boots up, and systemd is well, kind of follow a boot process, right? You know, your kernel kicks in, and then it launches your init. And so systemd would launch, and then it would control services from there. But with SysVinit, it's a little bit different. Your system boots up, your kernel fires up, and then the kernel calls a series of scripts. SysVinit is not a binary executable. Well, I guess it sort of is. There's a little bit of a binary. But the majority of what it does is all being driven by script files. We saw with systemd, it was driven by unit files, which aren't really scripts. They're kind of like descriptions. And then systemd knows what to do with it and executes. SysVinit just runs scripts. Whatever happens to be in the script, it runs. And you can put literally anything in there, like starting a service and passing parameters to a service and checking to make sure the service is running or the permissions are set right. All of that is different things that SysVinit can do. And it does it in a significantly different way than systemd does. Now, many people feel that systemd is the better of the two options for modern systems. But if you've got a server that millions of users rely upon and it needs to be rock solid, SysVinit's been around since the late 1970s, early 1980s. It's a very stable, tried and true system. And that's why when you go out and look at servers, you'll find many still do it. Let me give you an example. If you're deploying Linux servers in Amazon Web Services, AWS, they have what's called Amazon Linux. And Amazon Linux is based off of CentOS 6, which is based on Upstart, which is based on SysVinit. So it's kind of a long chain. So when you go into an Amazon Linux AMI, it's going to be using SysVinit initialization strings and all of that. So you've got to know it. Amazon Linux 2, which only recently reached production, that one now uses systemd. So they're moving that direction. But most people haven't ported their workload over to it yet. So it is very, very common to encounter SysVinit systems.
So how do we know if we are using SysVinit?
Yeah, so you know, if you've just been hired on somewhere, you're taking over a server, you might not necessarily know whether it's running SysVinit or not. Maybe you've got all your distros and version numbers memorized and you just know off bat. But if not, we can double check. You know, I mentioned that the kernel is going to fire off the initialization system, and that might be systemd or it might be SysVinit. Well, that process of firing off initialization is the very first thing that it does. So we can just look at process ID number 1, and that will usually tell us whether we're running systemd or SysVinit, right? So for example here, let me take this. I've got two boxes here. This one is a CentOS 6 box. So it's running CentOS 6.7, which is currently supported. So this isn't like this is old and crusty. Like you can run this in a production environment. And if I come in and do a PSAUX, right? And I'm going to just pipe that into the head command. So I want to see the first 10 lines of my process list. When I look at the top processes here, process number 1 right here, fired off by root. If I come along to the side here, I can see that that's /sbin/init. If it just says that, /sbin/init, then odds are you're running SysVinit. Now, it's not a guarantee, and that's because some of the OS distributions, like Ubuntu will actually show /sbin/init also. But when you go and look at that binary, if you do an ls-l/sbin/init, when you look at the binary on an Ubuntu system, on a newer Ubuntu system, it will actually be a symlink pointing to systemd, right? So be careful with this one. In fact, if I go to like here's a CentOS 7 box, Let me get into a terminal here. And I'll do the same kind of thing with ps aux, and I'll pipe that into head. And that very first process I can see right here is pointing to /user/lib/systemd/systemd. So this one's pretty obvious, right? Ubuntu, at least in the newest ones, in the 18 releases, they're a little bit trickier. So always be on the lookout for that. But that's probably the easiest way to tell whether you're running SysVinit or not. So what you're looking for is that /sbin/init. That tells you what you're running. And once you've got that figured out, now you know that you need to administer the system a slightly different way than you would a systemd system.
So SysVinit starts right after the kernel, right? So then what happens?
All right, so SysVinit does have a binary, right? So it's /sbin/init, right? So our BIOS fires up on the system and it does all the hardware detection. Then it reaches out, it finds a hard drive partition, it finds the /boot partition, finds the kernel, launches the kernel. The kernel then turns around and says, okay, I'm a SysVinit system, and it launches /sbin/init. And when it does, it then proceeds to start launching a series of scripts. That init executable is then just going to run a series of scripts, and it runs them in serial, not in parallel. Systemd does stuff in parallel. It'll do more than one thing at the same time. But with SysVinit, it runs one script at a time, and when it finishes, then it runs the next one. When that's done, then it runs the next one, and so on. And it all kicks off with one script. Let me show you here on this system. If you go into /etc, you'll find a folder in there called rc.d, this folder right here. Now, this folder has changed a lot over the years. Originally, there were different folders. In fact, see all these light blue folders up here?
Yeah.
RC, rc0.d, rc.local, rc.sysnet. All these are like previous iterations of what SysVinit or like System 4 init or System 3 init. Like each of them kind of relied on different folders. So they're there for backwards compatibility. But now pretty much everything is tucked away inside of rc.d. And if we go into that folder and look, you'll see a number of subfolders based on all sorts of different stuff. And each one of these kind of influences what SysVinit does when it launches. And the main one that we want to pay attention to is this guy right here, rc.sysinit. When SysVinit starts, this is the first thing that it calls. It reaches out to this script and it executes it. And then from there, it will proceed to spawn other things. And there's a lot of things that influence what it's going to spawn, which are all kind of tied to parts of what it does. But this one's really the heart and soul of it. So /sbin/init runs, and it calls this script to then initialize the system.
Does that one script then call other scripts?
Absolutely. Yep. So it runs, and as it's finishing, it's then launching other things based on a certain criteria, right? And that criteria is what's called a run level. So notice all these other folders over here, rc0.d, 1.d, 2.d. Those are tied to run levels, right? So in Linux, you have 7 run levels, and each one indicates a different status of the machine. So for example, 0 actually means the system is shut down. Now, you might wonder to yourself there, like, why would I have a run level for shutdown? Well, you got to tell the system to shut down. And you might actually have scripts that are a part of that. When your system is shutting down, it needs to, basically perform a few tasks, maybe, stop writes to the hard disk or so on, and close out what it's doing. And those would be part of the shutdown script. You also have RC6 here, which is reboot. And so that's when your system is rebooting. It might have certain tasks. They might be the same. They might be totally empty. There might be no tasks tied to reboot and shutdown, but that's what those run levels are. The other run levels are kind of up to the distro, that they can operate in different modes. And they've kind of standardized on it. So most of the distros follow the same pattern, but it's not a guarantee. So always be careful. If you're not sure, check your distro's documentation. A lot of them will document what their run levels are in their initialization table. So there's a file. I'm just going to cat/etc/init tab. That's the initialization table. And when you look in that file, most distros do take the time to document the run levels. And so I can see right here for CentOS, and this applies to CentOS and Red Hat Enterprise Linux. I can see the 7 run levels. So see how 0 is halt? Halt is when the computer's turned off. And then 6 is reboot. 1 is single user mode. That means that only one user can be logged into the system and nobody else can be logged in, right? That's actually pretty handy if you're an administrator. Sometimes you want to modify a file, but it's always in use. somebody's accessing it or there's a file share, people are accessing it over the network, you need to make sure you have exclusive access to it. So you can boot in single user mode and you know you'll have that. There's multi-user without, it says without NFS. It's actually multi-user without networking. So it boots up in the full mode, but with no networking services at all. And that way you can ensure nobody over the network is getting into the system. If you think you've been hacked, here's a great way to boot and shut off your network. And now you can get in and examine the system and you know you're not communicating out. You have full multi-user mode, which is run level 3. And that's where you're saying, look, I want to boot up to a command line interface, but I'm allowing multiple users. People can SSH in or have more than one console. So a lot of people can be working in the system. That's the run level that most servers run at. Run level 4, it's actually not used. I don't think I've seen a distro yet that makes use of it, but it's available. So if you want to create a custom run level, that's usually what run level 4 is reserved for. Run level 5, it's labeled here as X11, but that means that we want to boot a GUI. We want to boot a graphical user interface, which is typically the X environment, but you might have some alternate user interface. And that one is multi-user with networking and a GUI. So it's kind of like the full shebang, right? It boots everything, and then you get access to the system. So those are the run levels. And looking at this /etc/rc.d folders, kind of hard to say, all these subfolders, rc1.d, rc2.d, these contain scripts. So when I boot into multi-user mode, command line only, rc.sysinit is going to run, and then it's going to look in rc3.d, and it's going to look at what scripts are in there. And look at all these scripts that I've got. I've got where it's starting the quota daemon and IP tables for the firewall, the LVM monitor for my logical volume manager, network manager is starting, postfix, all these different things will start when my system starts. These are tied to various services, right? Postfix, that's an email service. SSHD, that's my secure shell daemon. These are all being started. That's how it knows what services to fire up, and it's all controlled by the run level. If I look in, let's go into rc5.d. All right, so this is if I boot with a full GUI, and I'll see things are a little bit different. There's a lot of overlap, right? So I still see SSHD right there. I still see postfix, right? But I'll also see some things in here that are tied to X Windows. Let's see, I should be seeing GDM in here somewhere. I must be skimming over it. It's hard when you're under pressure on the show, but somewhere in here is GDM, which starts the graphical device manager to have to let you get logged in and all of that. So it's additional things that'll get loaded. You may see variations depending on which run level you boot. That's what all happens right here. Then there's one more thing that may get loaded, but typically doesn't. Back in rc.d, there's one more file, rc.local, okay? On really old systems, I'm talking Unix, right? It would run rc.sysinit, then it would run all the scripts for the run level, and then last, it would run rc.local, and that was your way to override anything else that was run before you kind of undo or redo stuff. Most distros have the file for backwards compatibility, but don't do anything with it. So it's usually empty, or it may not even be called at all. You'd have to check your run level scripts to see if they return to it, or check rc.sysinit. So like if I take a look at my rc.local, let's see what's in it. Yeah, it's pretty much empty. In fact, it just touches a file to indicate that it's locked, and that's it. So it's not used in this case, but it is there. So if you want to make use of it, you can. Versus if I take a look at rc.sysinit and take a look at that one, there's all sorts of stuff in here as it goes through mounting your disks or turning on SE Linux right there, doing all sorts of other stuff. This is a big deal, right? It's got a lot of work to do. rc.local is empty.
Do we have to modify the script files for each run level when we install a service?
All right, so good question, right? So I showed where SSHD was in there, right? So my SSH daemon is starting automatically, and it's in more than one run level, right? So if I install a service, like let's say I want to install a web server, right? So I'm going to install Apache. And when I install Apache, I want it to run when my system boots, okay? Well, if you notice with SSH, it was set to start at run level 3, and it was set to start at run level 5. They skipped run level 4 because it's not used, and they skipped run level 2 because run level 2 boots with no networking. So why bother starting a web server if there's no networking, right? Or SSH in that case. I might want a web server to do the same thing. So I want the web server to start with run level 3 and run level 5. So to do that, I mean, we could manually create scripts and put them in there. But what you'll find is that most of this is handled for us through a handful of commands. All right, let me just show you kind of how this works. So on my system, I'm going to do a sudo yum install httpd. All right, so I'm going to install Apache. Right, and apparently it's already installed. Great. So I've already got it installed. Now, once it's installed, you can go through and create scripts. So if I go back to, let's see, rc3.d and take a look in here, I don't recall seeing HTTP in the list. Oh, it is right there. K15 HTTPD. So I've already got it installed and it's already set to start. So I picked a bad example. All right, let's do, maybe we'll do a database instead. Is MySQL on here? Let me just skim the list to make sure I don't make the same mistake twice. All right, we'll do MySQL. So I'm going to do sudo yum install MySQL, and I'll do MySQL-server as well, and we'll do a -y so it just does it. All right, so it's going to install the database server. Now, when the database server is installed, it's not set to run automatically, or at least it shouldn't be. So I'm going to pull a list back up here and look, and I do see it actually created a link right there. So it's smart enough to create the links with what the default run level should be. If we want it on 3 and we want it on 5, it shows up right there. Now, what if that's not what we want, though? I don't want MySQL to run. Maybe I only want it to run when my GUI is running, but I don't want it to run when I'm booting to command line only, or something crazy like that, right? Well, you can actually manipulate these pretty easy without having to write or even edit the scripts at all, right? So you certainly can come in here. Most of these are just symlinks. See how they're light blue? If you pull up a long listing, you'll see they're almost all symlinked to the init.d folder. And in there is where these text files are kind of being created. But we can manipulate all of this a few different ways. The easiest way is to use the check config command, chkconfig, check config. What check config does is it lets you turn services on or off for different run levels. It defaults to run level 3 and 5. So if I do a check config, and then I say HTTPD on, that's going to turn, oops, I need to sudo that. Let me sudo that command there. There we go. That's going to turn on HTTPD for run levels 3 and 5. If I boot at run level 1 or 2 or 4, it's not going to start, but 3 and 5, it will. And that's kind of its default operation. If I say off, then HTTPD is not going to start in run level anything, right? It's going to turn them all off, right? But I can go a step further with this command and I can be really specific. I can say, for example, check config HTTPD --level, and then specify the levels I want. The default would be 3, 5, like that. So run levels 3 and 5, that's where it's going to start. Maybe I want it to run, well, I'll just leave it at 3 and 5. Let's take MySQL. Oops. Sorry, I have to do one more option here and say on. There. So I left off the little on tag, so it got unhappy with me. Let's say that I want MySQL to run in run level 3 and run level 5 and run level 2, right? MySQL actually doesn't need the network in a traditional sense. You can use name pipes to access it. So maybe I want that database up and running even when the network stack isn't up and going. So for that one, I could do a sudo check config --level 235 MySQLD on. And now it's set to go with multiple run levels. So it's kind of a cool one. It's easy to lose track of this stuff, though, and we could go and sift through the scripts and figure out where it's set to run and where it's set not to. So if I go into /etc/rc.d/rc2.d and take a look in there, I can find, wait a minute, HTTP is in the list, right? It's actually symlinking to all of these, but the script is telling it only to run at a certain run level, and that run level is left off. So if we try and track it right here through these symlinks, it really doesn't help. We don't actually know if it's going to start or not. So a better way to figure out what's going to start and what isn't is to use check config --list. And that's going to list your services and tell you what run levels they're going to execute at. So if I run that, I get this nice big list right here, and it's got all 7 run levels with a simple on or off next to each one. So I can find HTTP right, whoops, if I can scroll back up to it. I can find it right here. And the mouse is my biggest challenge with this stuff. And I can see run levels 0, 1, and 2, it's off. Run level 3 is on, 4 is off, 5 is on, 6 is off. So just 3 and 5 are on. Even though I saw an HTTPD link in /etc/rc.d/rc2.d. And if I look at MySQL right here, I can see that it's a little different in that it's 2, 3, and 5 that are all turned on. Okay. This is a better way to see what's being run at each run level. If you just look at the links, you can't tell. You'd have to follow the link, and then you'd have to edit the script that it, or at least view the script that it links to. And in that script, it'll have an if statement at the beginning that says, like, if run level equals, and it'll list the run levels where it's going to start. That's a pain. Check config -- list. You'll see it all right there. And if you have a huge list, you can always pipe that into the grep command. And once it's in the grep command, you can just say, like, I'm looking for MySQL. And then you just get that one line. That makes life a little bit easier there. So pretty easy to verify. We could also just do it manually. Like maybe I'm not so concerned about when the system starts. I just need to use MySQL for a little while right now. Okay. So for that, you'll use the service command. And we can just come in and say sudo service and then start. And whatever the service is we want to start. If I want to start HTTPD, there we go. Oops, I got it backwards. Service HTTPD start. There we go. Sorry, you have to say the service name first and start second. I got it backwards. So sudo service start HTTPD, and now it starts up. And I can do the same thing with like MySQLD, which it'll probably be unhappy that I haven't secured it yet, but we'll do it anyway. We can start that one up. Yeah, it's warning me that I need to run the security startup script, but there it goes. So now those two services are running. But let's say I'm at run level 5 right now, and those are up and running, and I reboot my system. If those aren't set to start with run level 5, they won't be started when I reboot. So using the service command like this is not permanent. It's really just kind of a temporary thing just to get the service up and running and so on. And you can do a service status for any service and take a look at like HTTPD and, whoops, backwards again, darn it. Service HTTPD status, there we go. And if we sudo that one, I'll get it right eventually. We can see if the service is actively running right now. You may find where it started with the script and then something went wrong and it closed. And so even though rc.d is telling it, yeah, you need to start this at boot, it may not be booted. So this is a good way to quick check that and see. And I'll do the same thing with MySQLD. And I can verify right there. They're both up and running and happy.
Don, how does SysVinit know which run level to boot to?
I glanced over it earlier. So we kind of have some defaults, right? Where we're saying boot to the graphical user interface or boot to the command line. And your OS or your distribution will typically default to one or the other. That comes from the /etc/init tab folder or file that I opened earlier. If I cat that one, /etc/init tab. All right. So this is the file I brought up on screen earlier to show the run levels. Well, there's one tiny little line at the very end that I didn't mention. It's this guy right here that says id:5:init default:. All right. So this is telling the system what run level to boot to by default. So mine is set to default to run level 5, which is a full graphical user interface. If I'm setting up a server, I probably don't want the GUI. So I'll tell it to boot to the command line, to boot to multi-user mode, which is run level 3. So to do that, I would just edit this file and change that 5 to a 3. And then when you reboot, it's going to boot to the command line. And when you're ready, you can always change it back to a 5 again, and it'll boot up, and that'll be kind of the run level that it goes to. Now, that's if I want to make a permanent change. Let's say it's just a temporary thing, right? Maybe I'm having some kind of crazy issues with X Windows, and I just want to dump out and get rid of all of X Windows and then come back into X Windows, but not have to restart all my services or whatever. So we can actually change the run level whenever we want while the system is running. Now, it can have disastrous effects, so we need to be a little bit careful with it. All these scripts are going to execute and do stuff. But if you ever want to change your run level just temporarily, there's a command you can run, which is init. If you run init followed by a number, let me pull up the man file for that. So if you just run init followed by a number, it will immediately change your system into whatever that other init level happens to be. Now, if you're going to do this, be really careful. If other users in the system, you can really mess with them, especially if you're about to drop to single user mode. So you might want to use the who command to see who's logged in and how they're accessing the system to say, all right, here's people I need to contact before I change this run level. But assuming you're the only one in here, let me take this system and I'm going to go to multi-user mode, right? So I'm going to say sudo init 3. I want to drop to run level 3. And when I run that, my system drops to the eensy weensy tiny little console. And so I get to see that.
And we get out the magnifying glass.
Yeah, we'd have to use it here. So we lose all the, the cool screen enhancements and so on. Because now we're just in straight command line mode, and there we are, right? So now I'm kind of operating in this different world. X Windows has been completely unloaded, and it's executed the scripts found in that rc3.d folder to move me into this kind of mode. And I can switch back if I want by saying init. Well, I got to sudo that, sudo init. And then move back into run level 5. And when I run that, there we go. I see that it takes me back to my CentOS login screen, and I can get logged back in. And now I'm back into the GUI. So we quickly and easily change our run level like that. Now, most of the time, we're going to do it just like I did right there. It's going to happen fast. There may be times where you want to schedule changing the run level. And the official recommended way to do that is to use cron. You can set up a cron job to change the run level at a certain time if you want. That's one technique you can use. There used to be a command called telinit. And what telinit would do is it would let you set a time delay for when the run level would change. And many systems don't have the command anymore. And let's see if I do. I have to spell it right if you want to find it. I do have it. Okay, so there it is. Telinit, it lets you change system run level, so just like the init command. But the difference is it takes some options. The init command really didn't take any options. This one does. And one of the options is -t, which is in here somewhere. Well, I didn't see it, but it does exist. Where you can come in and you can say telinit, and then what number you want to go to. So I'll say I'm going to jump to run level 3. And then you can say -t followed by a time. And maybe I want to wait 30 seconds before I do it. And so I can specify that. I would need to sudo that command. And then I'll do that -t 30 and run it. Okay, so that's going to start that timer. Well, notice how mine just totally ignored the timer. That's because the telinit command, it's an old command. It's not supported by most. Now, a lot of distros don't even have it, and the ones that do don't fully support it. So it's kind of the old way. So instead, if you want to schedule it, you're a little better off by jumping in and doing a cron job to run init at a certain time.
Fantastic information. Managing services with SysVinit. Great episode as usual. Thank you, Don. And before we move on, I think you have something else you'd like to say.
Yeah, I've mentioned before that SysVinit is really old and that systemd is really new and shiny. And I personally like systemd, but I think that SysVinit is still really, really important. You are going to find many, many servers that are out there that rely upon it. And if you start jumping into other operating systems like FreeBSD and OpenBSD and those guys, they still use SysVinit too. Systemd hasn't made the leap over to those sides yet. So learning how this works is a skill that you'll be able to apply many different places. Definitely a valuable one to have.
Great advice. Thank you, Don. And here's some more great advice. Make sure you watch every episode of CompTIA Linux Plus. You're going to be so glad you did. It's going to help you now and in the future. And Don's done a great job putting this together for you. But keep learning, keep studying. Take advantage of the supplementary information in our course library, for instance. It'll help you do one thing. Go even further. Check it out. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
We will see you again soon.
Thank you for watching IT Pro TV.